Ladies and gentlemen, this is just an extension of what you were doing last week. I would like to demonstrate it for you one more time, and I'm also going to show you another strategy or method to help solve these guys. One that will work no matter what numbers you have. So, looking at the example that they give you, they say in the morning an octopus swam for 1/3 of an hour. In the afternoon, the octopus swam for 1/4 of an hour. How much did the octopus swim altogether? Well, altogether means we're going to add. So they want us to add 1/3 plus 1/4. Well, as you know, in order to add fractions, you have to have a common denominator, which these guys don't. You can use least common denominator, I abbreviate by LCD, to find a denominator that will work for these. So we're going to begin by listing multiples of these numbers. 3, 6, 9, 12, 15, 18. Now let's list some multiples of 4. 4, 8, 12, 16, 20. What number do you notice that both of these numbers have in common? It is a 12. So what you're going to be doing is changing both of these fractions into 12ths. So I'm going to show you how to do this the way that it is up here. I want to try this with you and see how you do with it. I'm going to change this fraction moving this way, okay? And I'm going to change this fraction moving this way. I think you guys can handle this, so I just want to give it a try with you. What do you multiply 4 by to get 12? Well, it's times 3. You do it to the bottom, you do it to the top. This is making an equivalent fraction, which we just did. We've been doing this for several weeks now. Now, I want you to imagine we're doing the same thing over here. Now, suspend your disbelief for a moment. It's okay. We are turning it into 12ths. Just think, on this side, you're moving to the right. On this side, you're moving to the left. What did we do to 3 to make it into 12? Well, we multiplied by 4. This is not like an equation because it's written backwards, but I just want you to remember this is the direction we're moving. 3 times 4 is 12. 1 times 4 is 4. We have now created new fractions that we can work with. So we have, I'm going to write this down over on the sides just so you don't get confused. With the new equivalent fractions we made, we are now going to add 4 twelfths plus 3 twelfths, and that would be 7 twelfths, because remember the denominator stays the same, and you simply add the numerators. Right here on your paper, they're asking for that 7 twelfths. You've got all of the information to fill in the squares down here at the bottom. They've also used a fraction bar to demonstrate that for you by turning thirds and fourths into twelfths, which we can also do just so that you can see it really well. So if you have 12ths, that means we would have 7 12ths that we need to represent. So 1, 2, 3, 4, 5, 6, 7. Do a little trimming over here. I made a gigantic fraction bar for no reason. 2, 3, 4, 5, 6, 7. And we had 1/3 and 1/4. This is what they've also shown you down here. We know that 1/3 is equal to 4 twelfths, right? And we know that 1/4 is equal to 3 twelfths. So if that's the case, do I have these in the right place? I don't. Let's fix that. You know how I know that was not correct? 1/3 is larger than 1/4. I should know that when I'm writing them down, but it's always good to check so that if you make a mistake, you can correct it. There it is on the back of that page. All right, we are working with another word problem. Catalina spent 1/10 of her free time reading and 4/5 practicing her flute. What fraction did she spend reading and practicing her flute? When you see the word and, it means for you to add. So we have 1/10 of her time reading and 4/5, practicing the flute. When it says add, and it wants us to add. So we want to add 1/10 plus 4/5. Well, that won't work because we don't have a common denominator. One more time through the way that we've been working on it. Some of you are going to look at this and realize right away, I can turn fifths into tenths. So instead of having to find least common denominator for both of those numbers, you can see how it can change. So I'm going to come over here and I'm going to turn 4/5 into tenths. This one's fine because it's already in tenths. What do I do to 5 to get 10? That's times 2. If you do it to the bottom, you need to do it to the top. 4 times 2 is 8. Now, we've created equivalent fractions. We're not using that one anymore. We're using the equivalent fraction. And so now we can say 1/10 plus 8/10 is 9/10. And we have solved that problem. You can use that information to fill in your boxes. As you travel through this, you've got the information from what I just talked you through over here to help you. You've got your tenths there, you have us adding them together, and you end up with 9/10. All right? Let's do one with my new strategy for you, okay? You ready for this? You can use whatever strategy you want to. You can use least common denominator. You can use noticing you could change one of the denominators into another number if there's one that you can change. Or you can use this third method. When you are in doubt and you might not have a whole lot of time, another method you can use is by simply taking the denominators and multiplying them together. The reason that this works is if you think about a fact family, you know that there are going to be 4 different math problems that you can create with that fact family, right? So if I take a problem like number 1 down here, which is 2/5 plus 1/2, just like before, I have to find a common denominator. Well, say I want a third way to do it. What I'm going to do is I'm going to create new equivalent fractions based on what happens if I multiply these numbers together. What is 5 times 2? Well, it's 10. Why don't we go ahead and put 10 as our new denominator? I know it's going to work for both numbers because multiplication is commutative, and you could switch their places and still end up with that same number. If this were part of a fact family, 10 would be up here, we would have a 2 here and a 5 here, and that would work, right? And we know based on that 2 times 5 is 10, 5 times 2 is 10, 10 divided by 2 is 5, and 10 divided by 5 is 2. So, let's go ahead and change both of these fractions into tenths. So I'm going to do it like I did last time, just kind of keep it in mind that that's this box and this is this box. This one's moving this way, this one's moving this way. What did I do to 2 to make it into 10? I multiplied by 5. Do the same thing to the top. So my new fraction over here is 5/10. Right? That's an equivalent fraction I just made. Over here, what did I do to 5 to turn it into 10? Well, I multiplied by 2. Over here, same thing. So 2 times 2 is 4. So there are my 2 new fractions to use. So back to the original problem, which was us adding those together. So I'm going to take 4/10, and I'm going to add 5/10. And how much does that make? The denominator stays the same. That would be 9/10. And I don't need to simplify it because 9 is already a prime number, so we're done with that one. So you can always take the denominators, multiply them together to make your new equivalent fraction. Let's do one more like that. Now, if you're more comfortable with the way that we've done it before by finding the least common denominator, you go ahead and use that. I just wanted to show you a different way. So let's do number 2 on that page. 3/4 plus 1/8. Okay, if I want to find a common denominator, I'm going to multiply them together. 8 times 4 is 32. If you're getting confused by me and my boxes, you can do it however you need to. You can come down here and you can rewrite that 3/4 and you can turn it into 30 seconds. And you can come over here and you can take 1/8 and you can turn it into 30 seconds. If you need to see it going the same direction, that's okay. You write it however you need to. Well, what did I do to 4 to make it into 32? I multiplied by 8. Do it to the bottom, have to do it to the top. My new equivalent fraction is 24 30-seconds. What did I do to 8 to make it 32? I multiplied by 4. My second new fraction, new equivalent fraction, is 4 30-seconds. What we're going to do next is add them together like the original problem wanted us to. Now, one of the downsides to using this strategy is that you're probably going to have to simplify at the end because you're not using the least common denominator, okay? So if you'd like to do this, keep in mind you might have to simplify at the end. So what's 24 plus 4? That's 28. The denominator stays the same. And I'm right, we definitely need to simplify. This is too big. So what factors do these have in common? Well, let's see. I could always try taking a 4 out. Be divided by 4 and see what I get. 28 divided by 4 is 7. 32 divided by 4 is 8. This is the fraction that I want, right? I know it's simplified because I've got a prime number here. Let's take this same problem and work it a different way. So this is us finding a common denominator, not the least common denominator, but just a common denominator. If we were finding the least common denominator, we would have to find factors of 4. So 4, 8, 12, 16, 20, and then we need to find factors, multiples of 8. It'd be 8, 16, 24, 32. Well, I don't have one that they have in common yet, so I have to come back up here to 4. Luckily, the next one is 24. So, let's see. Oh, look right there. We've got an 8. So, if we're using least common denominator, then we would be changing them into 8s. So, I'm going to take 3/4 and I'm going to turn it into 8s based on least common denominator. So, 4 times 2 is 8. 3 times 2 is 6. Now I need to do the same thing with 1/8. So 1/8, I'm going to turn it into 8s based on least common denominator. So guess what? 8 times 1 is 8. 1 times 1 is 1. So these would be the fractions that we could use. So we could do 6/8 plus 1/8, and that would be 7/8. So here's a second way to find it, right? So you can use least common denominator. You can multiply them together and know that you're going to need to simplify. Or you could notice that you could turn 4s into 8s, okay? So lots of different ways to do this. Do whatever's easiest for you. If you don't like simplifying at the end of a problem, you probably want to stick with what we've been doing. Least common denominator means that you shouldn't have to simplify at the end. All right, let's take a look at the back of this page and see if there's anything we need here. I think that you should be just fine with those. They're basically the same kind of problem. You've got a chart here to use to help you. And you guys have been doing really well with the which one doesn't belong part by figuring out the problems. I think that we'll be good to go. If you have questions about anything or need additional help, you can get a hold of me through Class Dojo, or your parents can also email me. Good luck, guys.